Standard 6.1 means I can use the kinetic energy equation or the potential energy equation to calculate the mass, velocity, height, or energy of a moving object. If a 500 kilogram car is parked on the top of a 10-meter hill, what is its potential and kinetic energy? Let's split our paper in half first so that we can look at each side separately. Let's start with kinetic. I know that my equation for kinetic is EK equals 1/2 mv squared. I'm going to list each of my pieces over here. If I think about EK, this is what I'm looking for. The mass of my object is listed within the problem, 500 kilograms. The velocity, if the car is parked, I know it has a speed of 0 meters per second. If I plug all of these variables into my problem, EK is equal to 1/2 m, 500 kilograms, times 0 meters per second squared. If I square 0, I get 0. If I multiply that by 500, I get 0. If I take a half of that, I get 0. So EK is 0 joules. We could have done that or figured that out without doing any of the math. If an object isn't moving, it doesn't have a kinetic energy. Kinetic energy is all about the movement of an object. Let's look at our other side. We're going to look at potential over here. My equation for potential is EP equals mgh. If I list my variables, EP is what I'm looking for. The mass of my car doesn't change. Gravity is 9.8. And this time we have a height of 10 meters. If I plug variables in, 500 kilograms times 9.8 meters per second squared times 10 meters. I can plug that into my calculator, and I should get 49,000 joules.